Hi class! Now we're going to solve and graph one-step inequalities. This is like solving an equation. If you want to, you can put a line under the inequality. Just like some people put a line when we were solving equations. Whatever you do on one side of the inequality sign, you have to do on the other. So we want to isolate w and get that variable alone. To do that, we need to get rid of the plus 3. And the inverse operation to adding 3 is subtracting 3. So we'll subtract 3 on both sides. 3 minus 3 is 0. So on the left, we get w. Our inequality sign stays less than or equal to. And negative 1 minus 3 equals negative 4. On a number line, we've got a closed dot at negative 4. Everything less than or equal to. So if you're taking notes, which is a good idea, pause it when you need to. I'm going to move on to the next example. Example 2. Negative 5 is greater than negative 2 plus y. So y is on the right side of the inequality. We want to get rid of negative 2. So we're going to add 2 to both sides because negative 2 plus 2 makes 0. On the right side, as I said, it makes 0, cancels out. On the left side, if you're down 5 and you come up 2, now you're only at negative 3. Or you can remember same signs add and keep. Different signs subtract. So here we have a negative plus a positive. So we subtract. And we use the sign of the larger number, or the one with the larger absolute value. So it's negative 3. Our inequality sign stays the same. So negative 3 is greater than y. So we have an open dot on negative 3. Negative 3 is greater than what numbers? Well, let's see here. We're going to test some points and see if they work. Is negative 3 greater than negative 6? Yes, it is. If I had picked a point on the other side, is negative 3 greater than 0? No, negative 3 is less than 0. So what I like to do is, before graphing it, always rewrite it with the variable first. So I would rewrite this as y is less than negative 3. So whenever you rewrite it, if you are rewriting it with y first, your inequality sign flips around. That kind of switched around. I don't know how to show that, but yeah. Or if you're looking at y here, going from y to negative 3, it is still pointing at y. If you read it in reverse, it is y is less than negative 3. So all the numbers to the left of negative 3 are solutions. Okay, so try this one on your own. Solve and graph negative 2 is less than or equal to x plus 3. Okay, so pause that and solve if you didn't already. Welcome back. We're going to subtract 3 on both sides of our inequality. A negative minus more, we're going to total be negative 5. And on the right we'll have x. When we rewrite this with x first, we'll flip around that inequality sign and have x is greater than or equal to negative 5. Filled in dot on negative 5, it'll go to the right. Okay, example number 4. 2x is greater than negative 4. It just says to solve. So we've been using adding and subtracting. Here we have times 2. Our inverse of multiplying is division. So we'll divide by 2 and get x is greater than negative 2. For number 5, x divided by 3 is less than 7. The inverse of dividing is multiplying, so we'll do times 3 on both sides of our inequality. 3 over 1. Okay, the times 3 and the divided by 3 will give us 1x. And on the right, we've got 21. Okay, example 6. We've got negative 2x is less than negative 8. Now when we divide or multiply by a negative, we're going to look closely at what will happen. So first off, a negative divided by a negative is a positive. But we're going to look at what happens to this inequality sign. If it were to stay x is less than 4, which I am questioning, let's see if those points would work. For negative 2x is less than negative 8. If that's the solution, it means the points to the left of 4 are all solutions. Let's try some of those points. Like let's try if x was 0. So is negative 2 times 0 less than negative 8? Well, negative 2 times 0 is 0. Is 0 less than negative 8? No. If we try 1, negative 2 times 1 is negative 2. Is negative 2 less than negative 8? No, also doesn't work. So let's say we try numbers on the other side of 4. So on the other side is numbers to the right of 4. Let's see if 6 would work. It's negative 2 times 6 less than negative 8. Well, negative 2 times 6 is negative 12. Negative 12, which is way down there, is indeed less than negative 8. So it turns out that if you multiply or divide by a negative, you need to flip the inequality sign. On example 4, we had a negative there, but we divided by positive 2. So we did not need to flip our sign. This one, when we divide by the negative 2, we're going to flip our sign. And right away at that step, we'll say we divided by negative 2, flip it to x is greater than 4. Okay, so we got 2 examples left of practicing this. So example 7, here to get rid of divided by negative 3, we would multiply by negative 3. So x would be, since I'm multiplying by a negative, reverse or flip our inequality sign. 2 times negative 3 is negative 6. So less than or equal to, we have a closed dot to the left. Okay. If you can hear my son whispering, that's Bobby whispering, "Are you done?" We're almost done. So example 8. If we divide by negative 5 on both sides, we get a negative 2. We're going to flip our sign. And then if we're also asked to graph, I would again rewrite this with x first. So x is less than negative 2 if you read it backwards, or just keep the sign pointing at x. So it'd be an open dot of negative 2 and go to the left. Happy solving one-step inequalities today.